Good evening, everyone. I am Mustafa Gamal, petroleum engineer, and today, inshallah, is the first day in coil tube course, which includes every detail in coil tube, not just general overview. So this course will have all equipment with all mechanisms, how it works, hydraulic circuits, everything. First of all, let me introduce myself to you. I am Mustafa Gamal, Egyptian petroleum engineer, graduated from Faculty of Petroleum and Mining Engineer, Suez University, 2019 class. Thanks God I was the first rank in my department. So I was eager to know every detail about coil tube when I worked with. When I graduated, I worked in my current company. It's Babetco, Badruddin Petroleum Company, Egyptian company. I worked as well service engineer with reverse operation, which includes well integrity operation, well head and subsurface, slip line, E-line, coil tube, hydraulic fracturing, and that's about it. That's all I want to say. About this level is dedicated to students and freshly graduate, which have never seen coil tube or has very, very simple background. This level is not for supervisors, for those whom have experience with this field of industry. So this level is not professional level. This is very basic level. Okay? So if you're professional, this level will not give any new information to you. Next level, inshallah, next 4 levels will have very specified information. It will have every hydraulic circuits. For example, reel, injector head, every circuit in power pack. We will study in detail reel, how reel is turned with reel motor, level 1 motor, everything. Also injector, hydraulic circuits within injector, mechanisms within injector. So everything within coil tube we will talk about in next levels, inshallah. Let's start. If we start with the history, how do you say coil tube starts? As an idea, how it starts? It starts in World War II, an operation called Pluto. Pluto operation or pipeline under the ocean. It was in 1944 when England wants to send fuel supplies to army in France. Excuse me for my English, I am not fluent. When England wants to supply fuel for soldiers in France, they want a very simple method because coastal tankers were frequently destroyed by aircrafts, so they want much more simple methods. So they invented this method in which a flexible pipe is wound around this core drum, like this one, and is laid across the English Channel between English and France. It is how the pipe was laid inside the channel. And this pipe was 3.5-inch pipe, large pipe, not the one we use currently, 1.5 inches. Sorry. And this how the pipe was received by soldiers in France and laid across the shore, connected with pipe works to receive fuel. The pipe was 2 main types. First type is highest pipe was mainly a lead pipe. The core was lead, L-E-A-D, lead pipe, surrounded by asphaltenes and resins backing to prevent leak. Then surrounded by wires steel wires to provide strength for the pipe, and finally by canvas to camouflage this operation. This was highest pipe. Highest pipe was very easy to lead across the ocean, but lead wasn't readily available, and also it has some problems when laid across the channel. So a second type of pipe was invented there. It was called Hamel pipe. Hamel pipe was made from milled steel. This one was very similar to the pipe we know currently, to the coiled tube known currently. It was a steel, not lead, not surrounded by many layers. It was a simple layer of milled steel. And this type was requiring a drum, like the one in the video, was requiring a drum to be wound around. So highest pipe was very much simpler to be laid across the channel, unlike Hamel pipe, which requiring a giant drum. So here we saw the pumping station in England. This one and this one was two and only two pumping station, and the two receiving station. This one was receiving from this one. This one was receiving from this one. Summarizing the pipelines from England to France, we can see that 280 miles of pipeline was laid across this pipeline, and this was the total length of pipeline, not the distance. It was consist of two and only two highest pipe and only two Hamel pipe. That's why, and that was because the distance was great, so pumping pressure here was also great. So this project was not so successful. So they invented later this project. This project was pumping from there to there. It laid 11 highest cables and 6 Hamel steel pipes. Notice this is called cables because it was made from lead, and this is called steel pipes because it was made from milled or mild steel. Okay. To be able to recognize this project was able to pump 3,000 tons of fuel on daily basis. Can you imagine the number? It was a huge number. And at the end of the war, it was recorded that 380,000 of ton of fuel, 380,000 of tons of fuels was pumped. This is the total pump. 380,000 ton of fuel. It was a huge number. It was really a huge number. So this was the first time a steel pipe was wound around a drum. This was in 1944 in World War II. Back to 1934, we can find well boring machine paper. In this paper, they use a hose, not steel pipe, a hose to drill wells. This invention made us the idea, or gave us the idea, that we can drill continuously without making connections. When we drill continuously with pumping, continuous pumping while drilling with special type of motors, not currently used motors, this invention was very, very useful for the idea of continuous pumping while moving. So later, Priestman et al. Invented the idea, which is previously used in World War II, when they inserted steel pipes into the well while drilling, not a live well, while drilling. So no pressure control equipment was used. While drilling, the steel pipe was wound around there, around the drum, and was given the radius of curvature around there by benders like gooseneck currently, and then back to straight pipe through pipe straightener. Okay, this is very close to the drum, currently used in coil tubing, gooseneck, currently used in coil tubing, and injector, currently used in coil tubing, but no pressure control equipment. Okay, and there were rollers in contact with the pipe, not chains like non-injector nowadays. So here there were rollers in direct contact with the pipe, not chains. Here were rollers like gooseneck. Gooseneck currently is rollers. Okay, and also there was pumping through, likewise swivel through the coil into motor and bit. So till now it was all about drilling, no live well intervention. So this led us to the second invention, which was made by Calhoun and Allen in 1951. In 1951, they invented the closest thing to the currently known injector. This was made of two chains rotating, one clockwise and the other in the reverse direction. This was rotating by sprocket here, in contact with each other, and the motor, single motor, rotating only one gear, so it's rotating the other, not two motors like nowadays. So this serves the basis of the currently known injector, which is first made by Bowen company. Bowen in 1962 invented the first injector. This injector was meant to inject antenna, not coil tubing. So this was made to insert antenna, but it was developed much further to insert coil tube into a live well. It used stripper, like the non-stripper elements. So this was in 1962 by Bowen company. So this was the history of coil tube, how it was made. First use of steel pipes wound around the real drum in World War. Then it was used with pipe benders and pipe straighteners by Priestman et al. Then it was inserted into a live well by Calhoun and Allen. Then finally, Bowen company invented the first coil tube injector in 1962. So the first section of our presentation has ended. Next, we talk about coil tube string manufacturing. How the coil tube string is made. The first process starts with low alloy carbon steel. As you see, this coil had a thickness of 0.087 inch and 3,500 feet of coil tube. The width of this is 55 inch. So this came to the factory as a raw material. Then we slit the 55-inch widths to much smaller widths. These widths make the circumference of the coil tube, and it determines the OD, or outer diameter, of the coil tube pipe. The thickness of this sheet will determine the wall thickness of the coil tube. Okay? So in here we slit the full width into much smaller widths, and we make this slices. Okay?